Hello and welcome. I am Poonam Parhar. I work in the Java platform group at Oracle. And in this session, I'm going to be talking about monitoring and troubleshooting tools that we find in the bin folder of our JDK installations. The mandatory statement from Oracle that I'm supposed to show here that whatever I say in this presentation may change in future. So before we go ahead and look at the troubleshooting and monitoring tools, a few words about troubleshooting. What is troubleshooting? So it's a systematic approach to solving problems. It involves 3 simple steps: understand the problem clearly, collect the required diagnostic data, and analyze the collected data. And what do we need in all these 3 steps is good troubleshooting and monitoring tools. So these tools allow us to monitor Java applications. The tools that we have available in the bin folder of our JDK, they allow us to monitor Java applications, profile Java applications, extract useful diagnostic information from them, and there are tools available to analyze the collected diagnostic data and even perform the after the fact analysis. And these tools can work locally as well as remotely. So the agenda of this talk is to look at the tools available in JDK bin folder. These tools are, some of these tools are monitoring tools, some are troubleshooting tools, and towards the end we'll also take a look at newly added tools in the recent JDK releases and some of the tools which have been removed from JDK bin folder. The monitoring tools which we would be talking about: JConsole, which is a graphic console to monitor and manage Java applications based on JMX technology; JPS, JStat and JStatD, which are based on JVM stat technology implemented in the JVM; and JMC, which was shipped with JDK until JDK 10 and has been removed from JDK since 11. It has been open sourced and it's available for you to download and contribute to it. So the first tool on the list is JConsole. JConsole is a GUI based monitoring tool for Java applications. It is a JMX client which implements the Java management extensions technology in the JVM, and it helps in monitoring and managing Java applications as well as the JVM, and you can monitor local and remote applications with it. There is a executable JConsole available in JDK bin which can be used to launch this tool, and we usually don't recommend JConsole for monitoring local processes because it itself consumes system resources and it can impact the performance of the process that you are trying to monitor. And for remote monitoring, use this option JMX remote.port to set the port number where at which port you can connect to your process running on remote system and monitor it using JConsole. And please remember, when you use JConsole for remote monitoring, use authentication JMX authentication flags to make sure your application is running securely and JConsole is connecting to it in a secure manner. So this picture shows how JMX clients, JConsole is one such client, how JMX client applications can connect to Java applications running on top of the JVM. So JVM has a JMX agent running inside it, and at the core of this JMX agent there is a mbean server. With this mbean server, the mbeans, which are nothing but Java objects running in Java applications, and these objects conform to the JMX object specification. So these objects, mbean objects running at the Java application layer, register with this mbean server in the JMX agent. So the mbean objects which are registered with the mbean server, they become visible to the JMX client application. So the attributes and operations that are made available through these mbeans become accessible to the JMX client, for example JConsole. So this JMX agent is basically a link between your mbeans which are there in Java application and your monitoring application, which is a JMX client. Snapshots of JConsole showing some of its capabilities. In the first screen, there is this is an overview screen which basically shows which gives you a summarized view of your application, your heap memory usage of the application, number of threads in the application, loaded classes and CPU usage. So this information is all obtained from the mbeans running registered with your mbean server of your application. And this extracted information is displayed using this GUI console. The memory view shows the memory usage of various memory pools in the JVM, and these memory pools could be Java heap memory pool or non-heap memory pools such as meta space, compressed class space or code cache. So you can view the occupancy usage of all these memory pools using JConsole. Number of threads, thread information can also be obtained using JConsole. You can browse through various threads available in your application. Clicking on any thread gets you the stack trace of that thread. Loaded classes and number of classes that had gotten unloaded since you started monitoring the application. So this information is really useful when you are trying to understand how many classes your application is loading or how many classes are getting unloaded. So VM summary view gives a summarized view about the information about VM and all the information that you had seen in the previous tabs. So this everything is available in textual format in this VM summary page. There is also an mbeans tab which basically gives you the ability to browse through all the mbeans available with your JMX agent. And you can all the operations and attributes of these mbeans become accessible to you through this tab. You can run any operation, for example, collect heap dump, collect histogram, start GC, stop GC. All these operations can be conducted through these mbeans. The next tool is JPS, Java Process Status Tool, which basically gives you the list of JVMs running on your local machine or running on remotely monitored machines. So it obtains process information from the process files created under hsperf data_user. So the underlying technology being used here is JVM stat, which can be enabled using this flag use perf data. So by default, this is always enabled, but you can disable it by using -use perf data JVM option. But if you disable the reporting of performance counter information by the JVM, then JPS tool won't be able to display the list of processes running on the system being monitored. And the list of JVMs reported can be limited by the OS level permissions, which means that if user A is trying to view processes and some of those processes were started by user B, but user A doesn't have the permissions available, the permissions necessary to look at the folders created under hsperf data. So user A won't be able to see the processes created by user B. This tool can list the JVMs running on local as well as remote hosts, and for remote monitoring there is another utility, JStatD, Java JVM stat daemon, which should be running on the remote machine. And for remote monitoring, it accepts this optional argument, protocol, host name and port number. So when you start JStatD, when you start your process making it available for remote monitoring, you would specify a port number and the protocol that it should be using. So when JPS needs to connect to this remote process, you need to provide the protocol name and host name and the port number. So by default, the protocol used is RMI and port is, I believe, 1099. On local host, the VM identifier which is printed by this tool is typically the OS process ID. Some JPS examples, so it accepts various arguments. JPS -H would show you the help for this tool, and JPS -M would show the arguments that were passed to the class or jar file when the process was launched. JPS -L would show the long list of fully qualified names of class or jar files, and -V is the verbose option, which would show everything, fully qualified class names, the arguments passed to the class or jar file, and the JVM arguments. And -Q quietens the output, which just shows the process ID of the running JVMs. Now, the second tool in the family of JVM stat tools is JStat, which basically prints JVM statistics reported by the JVM. So, these JVM statistics are written by the JVM in a memory mapped file, and these statistics are, we internally call them as performance counters. So, these performance counters are provided by the JVM using JVM stat technology, and the JStat tool is able to read that file, memory mapped file, which is available in hsperfdata_user folder, and presents that information to us. So, it can accept various options to print statistics for different components of the JVM, for example, class, compiler, GC. It can print GC usage or GC statistics for different memory pools of the garbage collector, and it can print compilation information of the compiler also. Again, for remote monitoring, JStatD, JVM stat daemon, should be running on the remote machine for it to be able to connect to monitor remotely running processes, and it accepts this optional argument for remote processes. JStatD, which is JVM stat daemon. So, it is basically an RMI application that monitors the creation or termination of JVMs on systems for remote monitoring, and it provides an interface through which JPS and JStat could obtain information about remotely running applications. Please note that there is no encryption or authentication with JStatD, so use this in production system with caution. Now, these are the tools we looked at: JConsole, JPS, JStat, and JStatD. And you might have noticed that some of these tools are experimental and have been experimental for a number of years. This might change in future or might stay in the same status for a while. So, after monitoring tools, we have a bunch of troubleshooting tools in JDK bin folder. The first one on the list is JCommand, which is a new tool added to JDK bin. and it can send diagnostic commands to the running JVMs and collect diagnostic information from Java applications. JDB, Java Platform Debugger, which implements JDI APIs and can be used to debug Java applications. JInfo, JMap, and JStack, these three tools can be used to collect VM configuration, can be used to collect stack traces, heap histograms, heap dumps, and the second last tool is JHSDB, which is a new tool added in JDK 9, and it can immensely help in debugging code files. JFR is a shiny new tool added in JDK 12 that can be used to analyze JFR flight recordings. All right, the first one, JCommand, Java Diagnostic Command Utility. So this tool uses attach API to attach to local running processes, local JVM processes. It doesn't have the capability to connect to remote applications because it uses attach API, which is available only for connections on local systems. And using this API, it can send commands to running JVM, and then the JVM can execute diagnostic routines based on the command it receives, and then can send back the results back to the JCommand, and the JCommand prints it out on console. And as I said, it can be used only on same local machine as the target JVM. Some of the popular commands that can be used with JCommand, we can obtain VMs, information about the VM that we are connected to. For that, we can use VM version, VM system properties, VM flags. So this would show us, what is the version of the VM we are trying to monitor, and what are the system properties, the values of system properties in that VM, and the values of JVM flags. Some GC specific commands, class histogram, class stats, and heap dump, which can be used to collect class histogram or statistics of classes, and can also be used to collect heap dump. Thread.print can be used to get stack traces of Java applications. Some Java flight recording, some commands related to JFR are also very useful. JFR start can be used to start a flight recording in an already running process. JFR check can be used to check all the recordings already running in a process. JFR stop can be used to stop any of the running recordings, and JFR dump can be used to dump any of the recordings to a file on the disk. So some examples of JCommands and some commands, some examples about the commands that can be used with this diagnostic tool. So before we go ahead and take a look at some of the commands, I would like to point out that JCommand carries its own documentation with it. If you type help, if you use JCommand against a process and type help with it, it will show you the list of commands available in that process. So if your process is running with JDK 8, the list of commands might be different when your process is running with JDK 9 or JDK 10, because we keep adding, we keep enhancing this tool, and with each version of JDK, we add new commands to it. So you have the same utility, JCommand, but new capabilities become available to this command as new features are added to JDK. First example is GC heap underscore info, which basically prints the heap occupancy information of various memory pools of the garbage collector. GC finalizer info prints the information about objects pending finalization. GC.class stats prints class statistics information, which contains a lot of data, a lot of information about the classes which are loaded in the JVM, the number of bytes occupied by the instance of that class, number of bytes occupied by all the objects created for that class, how much bytes the methods are occupying, how much what are the superclasses. So all this information gets becomes available when we when we use a class stats command with JCommand. JFR configure is one of the JFR related commands that can be used with the JCommand, and using this particular command we can configure the Java flight recorder, and we can set the configuration that should be used when we start new recordings in Java processes. Compiler specific command, compiler.code cache. So this basically prints information about code cache. So code cache is a memory pool in the JVM where all the compiled code generated by the JIT compiler is located, is stored. So the code cache in earlier versions of JDK was just one chunk of memory, but in later versions, in newer versions of JDK, we have segmented code cache, to have better optimization for the compiler. So this segmented code cache would have a segment for non-profiled methods, for profiled end methods, and for non-end methods. Using this command, compiler code cache, all this information is printed out on the console. Compiler.code list prints out the names of live methods which have been generated, the compiled code which has been generated by the JIT compiler. Perf counter print, as I said, JVM has this, the perf data counter feature. It reports these performance counters which are used by JPS and JStat tool. These counters can also be printed using a JCommand tool. The command that can be passed to JCommand to do that is perfcounter.print. So it simply just prints the name and the value of those performance counter made available by the JVM. Now, to visually understand how JCommand works and how it sends the commands to the JVM. So JCommand attaches to the running JVM using attach API, and the commands are sent over to the JVM through it, based on the command, the specific diagnostic routine is executed within the JVM, and then the results are returned back to the JCommand. And as I mentioned before, this tool can attach to the JVMs only running on the local machines. The remote monitoring capability is not available with JCommand. Next tool on the list is JDB, Java Debugger. It's a command line debugger for Java class files. I know not many people use this tool these days because fancy IDEs have more enhanced capabilities for debugging Java applications and classes. But for quickly step through your application when you don't have heavyweight GUI applications available on your system, this is quite handy. It can accept the various options to attach to the class files, and accepts the arguments that should be passed to the class file. It implements JDI interface. It's a component of Java Platform Debugger architecture, and it can perform inspection and debugging of a local or a remote Java virtual machine. So, before we move on to talk about JInfo, JMap or JStack, I would like to talk about their capabilities and how those capabilities have changed between various JDK versions. So, in JDK 8, these three tools JInfo, JMap and JStack could connect to local processes. They had the capability to attach to core dump files, and they could also be attached to applications running on remote machines. But in JDK 8, they were able to do that for to be able to connect to core dump files or to attach to remotely monitored applications. They were using the underlying technology which is named as serviceability agent. So, serviceability agent was providing the support for these three tools to be able to connect to core dump files and remotely monitored applications. But in JDK 9 and later versions, that support was removed. So, in these post JDK 9, JInfo, JMap and JStack are not able to debug or attach to core dump files or attach to remote applications. So, they use attach API to work with only locally running JVM processes. All right, so with that, let's talk a bit about JInfo. JInfo, as its name suggests, it extracts information about the VM, which means it can, basically it shows us information about JVM flags and system properties. And using this tool, you can enable or disable a flag, or you can set the value of a flag, and it can print values of all the system properties as well. JMap, Java memory map. So, this is extensively used tool. The two main interesting features it has is printing this heap histogram, heap objects information, and the ability to collect heap dumps. And there are various flags options that can be used with the JMap tool. The first one is a CL stats, which prints class loader statistics information, finalizer info, which can be used to print objects pending finalization, and then minus histo can be used to collect class histograms, and minus dump can be used to collect heap dumps from your running applications. And in JDK 9, heap info and shared memory mapping capability, print the information about heap and shared memory mappings was removed in JDK 9. It's still available in JDK 8. So, these two capabilities were moved over to JCommand tool. JStack, which is the one thing most commonly used tool to collect Java stack traces. It can print thread dumps, it can create thread dumps, and while it does that, it runs deadlock detection and reports if there is any Java level deadlock among threads running in the application. An important option that can be used with JStack is -L, which prints the concurrent lock information. So, by default, if you obtain a stack trace from an application, from a Java application, it does not print the concurrent lock information. So, we need to use -L to get that. The support for -F and -M has been removed since JDK 9 because the serviceability agent support was removed, and -M option is really helpful when we are trying to get mixed mode stack traces, which means that the stack trace would contain both Java level frames as well as native frames when you print out the stack trace. Comparison of JCommand with the older individual tools. So, the capability of JPS, JInfo, JMap, JStack and JStat is available. So, most of the functionality provided by these individual tools is available in JCommand. Instead of using these individual separate tools, it's easier and convenient to use one single command with different options that can be passed to this command utility. All right, JHSDB, so Java Hotspot Debugger. So, this tool was added in JDK 9. As I mentioned before, the capability of attaching to code dump files and remote applications was removed from JInfo, JMap and JStack tools, and that capability was moved over to this new tool JHSDB. So, if you are interested in debugging code files created by your Java applications, or if you have a hung process, hung application and you would like to collect stack trace from that application, this is the tool to use. So, the underlying debugger which is used by this utility is serviceability agent, and it uses serviceability agent to analyze and look at code files. The options that can be used, the different commands that can be used with this utility, CLHSDB, which can be used to launch command line hotspot debugger, HSDB, which can be used to launch GUI based debugger, hotspot debugger. Debugd, it starts a remote RMI server through which JHSDB can connect to remote applications. JStack, if you are interested in collecting stack traces from your code dump files or from remotely running applications. JMap, so all the capabilities which the individual JMap tool had, you can do the same with JHSDB, JMap for code files and remote applications, and similarly for JInfo and JSnap. So, JSnap is the tool which can print performance counters of a live running Java application. So, one thing I would like to point out here is the slide says that it can be used to monitor live processes as well, but since it uses serviceability agent to do that, serviceability agent halts the process while it is examining it. So, if you use JHSDB to connect to a running process, the process would be stopped for the time duration where as long as JHSDB is connected to that process. So, keep this in mind when you are using this tool to examine live processes. This is mostly useful when there is a hung application and you want to extract diagnostic information from that hung application. All right, so JInfo, JMap, JStack, this is the picture from the previous slide. These three tools lost the ability to connect to code dump file and remote applications since JDK 9, but that capability was moved over to JHSDB because JHSDB uses serviceability agent to do all these three. So, JHSDB would use serviceability agent, and to connect to live processes, it would use this non-cooperative method to attach to live processes, and the process would be paused, halted as long as this tool is connected to the process. Some examples of JHSDB, CLHSDB can be used to launch a command line tool, a command line debugger, and typing help on that would show the list of commands available in that utility. It can be used to see stack traces from core files. Here you can see stack trace for main thread. You can inspect address address in the Java heap, any address in the Java heap, to look at the objects allocated at that address, and search any value in the heap or in Java stack traces. Not Java stack traces, Java stacks. HSDB tool can bring up the GUI based hotspot debugger using JHSDB tool, and here we can see that it shows all the Java threads available in Java process or from core file, and it can inspect any objects in the Java heap. You could use this tool to look for any specific value in the heap, or you can also obtain object histogram from core files. You can also get a snapshot of objects present on VM objects present on the stack memory of any Java thread. JStack command can also be used directly with JHSDB tool to get stack trace, and here mixed mode stack traces are available. JMap tool can be used with JHSDB to get histograms, to get class statistics, to create a heap dump file, and JInfo can also be used with JHSDB. From the core files we can get VM configuration, system properties information, and values of JVM flags. JSnap prints the performance counter information available in the attached process. So those were the tools which are available, were available since, until JDK 11. In JDK 12, we added another command line tool, JFR tool. So it's a command line tool which can be used to look at JFR files. We have JMC tool, which is a GUI based tool to analyze JFR recordings. But in situations, in environments where it is not possible to use GUI based tools, or those tools are not available, this tool can be very helpful and can be very handy to use. We added this tool in JDK 12, and it will be made available in update 6 of Oracle JDK 11. Some of the commands and options that can be used with this command line tool: you can use print command to print events. You can filter out events of a specific category or a specific event matching a particular string. You can also configure the stack depth of the stack traces printed with the events, and you can provide the file name of the path and the file name of the recording that you would like to examine with this tool. So we looked at JCommand. We keep enhancing this tool. We keep adding more and more commands, diagnostic commands that can be used with this tool as we add new features to JDK. Java Platform Debugger, JMap, JInfo, JStack, JHSDB, which can be used to troubleshoot, debug core files, and JFR command line tool. So some of the tools which were removed in recent versions of JDK. So JDK 9 removed Java Visual VM, JHAT, and JSA debug T. JDK 11 removed JMC from its bin folder, and JMC has been made available as an open source project. So let's talk about these tools that were removed from the JDK bin folder. Java Visual VM, it's not included in JDK 9 anymore, and it has been open sourced. The open source project link is given here. And the Java Visual VM had the capability to monitor profile applications as well as analyze heap dump files. So there are other tools that provide the similar capabilities. We can use Java Mission Control, JConsole for monitoring and profiling, and Eclipse Mat can be used to look at heap dump files. JHAT, which was removed in JDK 9, and this tool was is a web application that can be used to explore heap dumps through a web browser, and it provided a wide range of predefined queries and object query language, where you can construct your own queries to explore objects in heap dumps. So this has been removed, but there are other tools that can be used to explore, analyze heap dump files. JSA tool was removed in JDK 9, and this tool was was used for tools to be able to connect to remote applications. So up until JDK 8, JStack, JMap, and JInfo could remotely connect to Java processes through this daemon. But now this debug server can be launched using JHSDB debug command. Java Mission Control, which is there in JDK bin folder until JDK 10, it was removed in JDK 11, and it has been open sourced. The second link here provides detailed information about how we can build JMC. So JMC had this MBean browser, MBean Explorer, and it is an excellent tool for analyzing JFR files. Some snapshots of JMC. JMC can be used to look at MBeans registered with MBean server, and it can be used to analyze JFR files. So a few words on JFR. JFR, even though it's not a tool available in bin folder, but I wanted to give a quick update on JFR, what's happening in the JFR world. JFR also has been open sourced in JDK 11. It was a commercial feature earlier prior to JDK 11, and it needed the use of this flag unlock commercial feature option. But with JDK 11, we no longer need to use this option to be able to use flight recorder. JDK 9 added flight recorder API, and JDK 10 we have this new event, old object sample event, which can be used to troubleshoot memory leaks in Java applications. A lot of performance enhancements have been added to JFR, and there is a new ability to dump recordings even at VM crashes or out of memory errors. And new improved events have been added to JFR, for example, events related to SafePoint, code cache, compiler, and we keep adding new events to flight recorder as we add new features in JDK. All right, to summarize what we have looked at so far, in JDK bin we have an enhanced tool, JCommand, and we keep enhancing it. New tools were added, command line tool JFR and JHSDB for postmortem analysis. JFR tool was added in JDK 12, and JDK 9 added JHSDB. And here's the list of tools that were removed: Java Visual VM, JHAT, JSA debug for remote monitoring capabilities, and JMC. All right, that's all I had for this session. Thank you for your time.